Assalamualaikum and very good days to everyone. Hopefully all the students in the good health. So for the class today we will conduct in the FOC. So we proceed for the chapter 2. We already complete for chapter 1. So for the chapter 2 is the second order differential equation. So part 1 related of the homogeneous equation. Okay, so for the previous this symbol, this represent for the first ODE. Okay, or also we know as the dy dx, or others term dq dt and so on represent for the changing. Okay, for the changing. And for this topic we focus for the second order y double prime. Okay, so this is the second ODE, also known as the d square y dx cos 2. So this is the notation represent for the second order ordinary differential equation. Okay, so how we can identify or determine whether the ODE, second order ODE, is the homogeneous or non-homogeneous is depend on this form. So they have the AY double prime, BY prime, and CY, and also for the FX. So here is the important parameter that you need to analyze, either the ODE is the homogeneous or not homogeneous. Okay, the ODE can be categorized as the homogeneous if the Fx equal to 0. Okay, if the Fx equal to 0, and if Fx not equal to 0, okay, there is we call as non-homogeneous. That's all. Only this form is general form for the ODE, and make sure the Fx must be equal to 0, and then we can categorize that the ODE is a homogeneous. Okay, so in this topic we focus, in this chapter 2.1, we focus for the homogeneous equation of the second ODE. So this how we can solve the second order ODE. So the basic or the framework of the ODE is still similar as the first ODE, where from the ODE we can solve, we get the general solution, and then we can solve by using the initial condition to solve for the arbitrary constant value. Okay, to get the arbitrary constant value, and then we can obtaining the particular solution. This framework similar, still same for the first order, second order, and so on. Okay, first order or second order is same. After you solve for the A, and then you can get the general solution using this condition, and then you can get the particular solution. So in chapter 2 we focus for the second order. Okay, so solve by obtaining characteristic equation. Characteristic equation is obtained by substitute. Okay, y double prime we substitute to the m square, y prime we substitute to the m, and y we substitute to the equal to 1. And to form the auxiliary equation, we have the purpose. So why we need to form the auxiliary equation? Because we want to determine the roots. Okay, the roots of the equation. Okay, this is the 3 steps to solve the second ODE. First, we need to obtain the characteristic of the equation, determine the type of equation roots. So this is important. We need to find the roots. When we determine the roots, so we can know which one is their general solution. Okay, find the solution equation by referring the table. Okay, we can refer this table. Okay, when you have the distant and real root, that means you have the two different roots, root 1 and root 2. So this is the general solution. So when you determine here, then you need to substitute for the my and m2. This is the maintain a exponent m1x plus b m2x, so maintain. So if your roots is the real and equal roots, that means your r equal, so the m is the equal. And if your complex roots, if you find the roots is the complex, so you need to using this formula atau this solution for your general solution. Okay, all this depend on the roots. Either the roots is the distant and real, real and equal, or complex root. So how we can determine the roots? So either by using the factorization. So you can find m plus minus a, and then you can determine what is the m. And also the first thing, so I'm usually before proceed to determine the roots for the each auxiliary equation, so I prefer to solve this equation. Okay, you solve this equation first. Solve this first, and then if you found the b square minus b larger than 0, so that means the roots is the distant and real. If you solve this one equal to 0, that means your roots is the real and equal. So for the complex roots, when you solve this one, you can get less than 0. So you know the roots is the complex. If you solve this one equal to 0, so you know the roots is the equal. So this one, if this value larger than 0, so you know the roots is the distant and real root. Okay, let's say, let's go to proceed for the example. Okay, so we solve for the distant and real root first. So how we can determine either the ODE have the distant and real roots, so you need to solve for the b square tolak 4ac. This is step number 2. Either the larger than 0, equal 0, or less than 0. Okay, let's say you have this is the distant and real roots. So let's say you have this one because equal to 0, so you know this is the homogeneous equation. So here is the initial condition. Okay, so you look here. So for the previous, the step 1, okay, the step 1, so m double prime, so y double prime, you need to change to the m square. Y prime, you need to change to the m. Okay, y you need to change to the 1. So by using this substitute, so you can get m square plus m minus 2 equal 0. Okay, this is the first step. You need to substitute all these things to the m symbol, and then you get this auxiliary equation to form the auxiliary equation. Substitute this one to form the auxiliary equation, and then you check this one, either the distant and real roots, equal roots, or complex root. So I prefer, before proceed this one, I check for the b square minus 4ac. Okay, I check here first. So b, this one a, b, c. So b square is 1 square minus 4 b1, okay, b1, okay, minus 4 a is the 1, okay, c is the negative 2. Okay, c is the negative 2. So when you complete here, you can get 1 minus 4 minus 8. So you get the 9. 9 is larger than 0. Larger than 0, that means is a distance and real roots. So that means they have the two roots, R1 and R2, or M1 and M2 from here. So you can find the roots by factorize. Okay, factorization. Okay, factorization. So okay, 1 M sorry, m minus 1, m plus 1. So you can get m square, okay, plus m minus m. Sorry, wrong. Not correct. M plus 2 m minus 1. Okay, you get m square minus m plus 2m minus 2. Okay, so you can get m square plus m minus 2. Okay, sama lah. Okay, similar here. So that's mean equal to 0. So your m equal negative 2, m equal dengan 1. Okay, you bring here m plus 2 equal to 0. So you get m1 is the negative 2, and m minus 1 equal to 0. So m2 equal to 1. So you can get the particular solution for here, for this equation is the y equal a exponent, so negative 2x plus be 1, m2 is the 1, so equal to x. So this one we call as the particular solution. So and then the given here initial condition, so you need to find this one general solution. So the given the initial condition, so you need to find the particular solution. So you need to use here both initial condition to solve for the initial condition. Okay, let's you try what is the final answer for the particular solution.